All right, so this is the end of the unit review, organic review. So please make sure you have reference tables P, Q, and R available, possibly a scrap sheet of paper to do some drawing if you don't have enough room right here. So let's jump right into it. Which compound is a saturated hydrocarbon? So saturated means all single bonds. And hydrocarbons means only H's and C's. So anything that has an O or something else, a nitrogen, that's not a hydrocarbon. So for the first one, propanal. Propanal, if I'm looking on table R, propanal is an aldehyde, which means it has an oxygen, not a hydrocarbon. The rest of these are just alkanes, alkynes. So those are all hydrocarbons. But which of those is single bonds? Well, that would be the ending ane, propane. So there's our saturated. Which compound is a member of the same homologous series C3H8? So homologous series are found on table Q. Let's figure out the general formula. If N is 3, I have 2 times N, which is 6, plus 2 is 8. So this is CnH2n plus 2. That is called an alkane. So an alkane has all single bonds. So 2 ways you can do this. You can use table Q, which is what I'm going to do, or go ahead and draw them. Draw them all out, and then you can see that. I am not going to draw because this mouse is terrible. So who is an alkane? It would be choice 1, because I have double 1, so 2, plus 2 is 4. What is the name of the form of the structure below? Okay, so first of all, we need to find the longest continuous parent chain. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Doesn't matter. I'm going to call this the parent chain. 1, 2, 3, 4, 5 is pent. And we have all single bonds, so that's pentane. Then we have a branch coming off here. It's a 1 carbon branch. 1 carbon means meth, and then you end it with YL to show that you are a branch. Then you need to tell the location of that. So let's number the carbons 2 different ways. 1, 2, 3, 4, 5. So this would be 4 methylpentane. But remember, we always want the lowest numbering scheme possible. So if I number this way, it's 1, 2, 3, 4, 5, 2 methylpentane. That is the lower of the numbering schemes. That is my answer. 4 methylpentane. That's tricky. Remember, we want the lowest numbering scheme possible. Which compound is a saturated hydrocarbon? I see oxygen. That's not a hydrocarbon. So then maybe we should draw it CH2, CH2, CH3, CH3, or we can just use our general formulas. CH2, CH2, that's C2H4. This is C2H6. Which of those has all single bonds? 2N plus 2. That's this one. It is CH3, CH3. Feel free to draw it if you'd like. It's no problem. An unsaturated hydrocarbon would not have single bonds. It's going to have a double or a triple bond. So it's going to get rid of any CNH2n plus 2. So methane's gone. Double the carbons and add 2. That's gone. Double the carbons and add 2. That's gone. Double check. Is that correct? Well, double the carbons, that's an alkene. So that's our answer. Which is an alkene? That's double the carbons for hydrogen. 6 is not double to 2. This is not and not. Draw it out. Folks, if you're always struggling, draw them out. That's a great strategy. A carbon-to-carbon triple bond is found in which? Well, first of all, you need to look for what does it mean to be a triple bond. That's an alkyne, which means ending of YNE, which means that's our answer. Ine. Butane, all single bonds. Butene, there's a double bond. Butanone is a ketone, which means you've got a carbon to oxygen double bond, not a carbon to carbon triple bond. What is the total number of electrons shared between two carbons? So I have a triple bond. I'm just going to make it bigger. In a triple bond, you have two atoms sharing electrons. If there are three bonds, each of them has 1, 2, 3, 4, 5, 6. So total electrons shared is 6. How are we doing? Good? If not, go back, check the notes, email me if you got questions. Cyclic hydrocarbons, this is just a definition. This is benzene. Benzene looks like this. And every point is carbons. And then you do alternating double bonds. Super messy, I apologize. Which atom can bond to form chains, rings, and networks? Hey, that's organic chemistry, that's carbon. Butanol and butanone have different chemical and physical properties because of, well, what the heck's butanol? So I'm going to look on table R. Butanol is an aldehyde. And aldehydes have C double bonded O to an H at the end of the chain. Butanone is a ketone. And ketones have a C double bonded O somewhere in the middle. So they have different functional groups. Do they have different molecular masses or molecular formulas? Well, first of all, they don't have different carbon atoms because but means meth, eth, proth, but, 4. GFMs and molecular formulas and masses, they're not going to be different because the only difference is where the oxygen is located. So they're going to have the same mass, which is incorrect. Let's take a look here. Get my pen. All right, so I think they're probably going to be asking you to find where carbon is forming more than 4 bonds. Now, technically, this should have its valence electrons in there, but that's fine. So we're going to call that okay. 1, 2, 3, 4 for the left carbon. 1, 2, that's okay. 1, 2, 3, 4, that's okay. Here it is. This carbon right here has 1, 2, 3, 4, 5 bonds. And carbon cannot form 5 bonds. That's wrong. If you wanted to make that correct, all you'd have to do is get rid of one of the H's. I could get rid of that one or the bottom one. Doesn't matter. Just get rid of only one. Isomers. Isomers have the same number of atoms, just different arrangements. So it's like you get, 100 Legos, build something, and then break it apart and take those same Legos and build something completely different. You can do that. So it looks like and I'm going to try to make it over here. C2H 1, 2, 3, 4, 5, 6, O. That's A. B is C2H6O. Oh, hey, that's the same thing. Let's check out, let's just continue. C is C3H6O. And D is C3H, I gotta count this. Oh my gosh, 1, 2, 3, 4, 5, 6, 7, 8. Oh, yeah. So you see how these have the same number of pieces, just arranged differently? That's why they're called isomers. The organic compound, which is this, is what? Well, let's just draw it. I don't know. CH3. By the way, you know that there are H's at the end of each of these bonds. I'm just not drawing them because it's understood. CH3, CH2. CH2. We need a CH and an O. Carbon only has 1 bond already. So we need 3 bonds, and we've only got 2 things. So that means, there we go. So what is this? Where do you have a functional group with a C double bonded O at the end of the chain? That is called an aldehyde. Aldehyde. Choice 2. All right, let's move this along. Why is that thing traveling with me? Let's get rid of this. Number 15, what is this? Let's look for the functional group. C double bonded O to an OH. I'm going to check reference table R. I'm going to see that's an organic acid, sometimes known as carboxylic acids. This is not asking what functional group it is. This is asking what is the name. So here's our functional group, which we just decided was an organic acid. So if we're looking on table R, the way to name an acid is ending it with oic acid. So we have 1, 2, 3, 4, 5 carbons. That's pent. Normally it would be pentane, but this is pentanoic acid. This is exactly the one from the reference tables. So that would be choice 4. Which is an alcohol and an acid. So alcohols just have an OH group. So who's got an OH group? Oh, D does. So anything without D, we don't want. D is the alcohol. Here it is. Which is an acid? Acid is C double bonded O to an OH. Here it is, B. So it's choice 3. What is A? C double bonded O at the end of a chain. This is called an aldehyde. C double bonded O in the middle is called a ketone. Now, if you're saying to yourself, I don't know these, how is she getting these? You absolutely need to go to reference table R and just take a look. I'm doing this faster because I've done this for 15 years. And also, it's my job. If it takes you longer to determine which functional group that is fine. Go ahead and take your time. What is the functional group? The only unique structure here is just an OH. Which of them has just an OH? That's an alcohol. Let me scooch this down. What has the IUPAC name for the compound that has that? And I do hate it when it goes onto 2 separate lines. I apologize. CH3, let's draw it. CH2, CH2, CHO. So carbon already has 1 bond, but it has to get 3 additional, and there's only 2 things. The only way we can do that is making a C double bonded O, because hydrogen can't make a double bond. So this is the only way we're going to make it work. Okay, so what is that? Meth, eth, prop, bute. So we've got to have bute as our prefix. And then what do you call this? This is an aldehyde. So this is butanal. Butanal. Okay, going back up here. Ketones. Ketones have a C double bonded O somewhere in the middle. For the sake of this, I'll draw it. HCOOH. So here's my C. I have an H. I have a COOH. What is that? Take a look. It's an organic acid, not ketone. Number 2, CHCHO. Okay, I know that looks like a mess, but let's start with our C. And I've got an H. Can I do this? Tell me if I can do this. So that would be HHO. Is that good? No, because you need 4 bonds, and we don't have that. So if I make that a double bond, that works. But that's not exactly how it looks. So it might not just bring you to it. So the double bonded O is usually going up top. This is the same thing. Get rid of that guy. So it looks like we have a C double bonded O. Ketone. That could be our answer. Let's take a look. CH3, CO, CH3. Oh no, that's our answer. Because you know what? This cannot be a ketone. Ketone has to be on the interior carbon of a chain. How is there an interior if there's only 1? This is an aldehyde. I got tricked. This is our answer, 3. 21, name it. Looks like, again, we have a ketone. C double bonded O somewhere in the interior. Meth, eth, prop, bute. Butanone. Why is it not butanal? Because that would be at the ending. Why is it not prop? Because there's too many carbons. Which class of compounds contains at least 1 element from group 17? Group 17, those are called the halogens. So these are the halides, halogens. That would be fluoro, bromo, iodo, and chloro. Which formula represents 2-chlorobutane? Meth, eth, prop, bute. So we need 4 carbons. So these guys are gone. So what's the only difference between these two? The only difference is where the chlorine is located. On this one, it's located on the first carbon. And be careful, it's not the fourth carbon. This is on the first, because you can number them from left to right or from right to left. So this would be the first carbon, whereas this would be the second carbon, and that's what we're looking for. So if you're ever confused, just number them right to left. I'm going to call that 3, chlorobutane. Number it left to right is 3. Right to left would be 2. So we want the lowest number possible. Sorry about that. 24. What is this? Let's draw it. CH3 COO. There she is. That's old Granny Esther's eyes. So ester, if you take a look on table R, C double bonded O to a single bonded O to a CH3. It's an ester. She's looking at you. Which is a type of organic reaction, formation of something organic, so an ester. Which compound has a general formula of ROR2? What is R? Go to the bottom of reference table R, and you will find that R just means group of carbons. So basically, this is saying who's in the center of any group of carbon chains, who cares how long they are? Single bondedly. And that is called an ether. Ether. We just missed the ether bunny. Number 27. What is this? Oh, I see nitrogen. So if you see nitrogen, this means it's got to be an amine or an amide. So it's one of those two. So let's check the differences. In an amine, you just start from ammonia. In an amine, you have, in an amide, you have the C double bonded O. So this has to be an amide. Which is an ether? Ether has the 2 chains of carbons separated by a single bonded O. That's 4. All right, so here's some organic reactions. Let's scooch this down. Looks like, and hopefully you've done the organic reactions worksheet before, so we don't have to go too deep into this. Looks like we're combining those two things. It's called an addition. What is X? Well, if we're combining them into one thing, this is an addition reaction. And the only things that can have an addition reaction are things with multiple bonds. So an alkene and an alkyne. So anybody who has double the hydrogens plus 2, that's an alkane. That's not what we want. 1 carbon, double it, 2 plus 2, 4. That's an alkane. Nope. Ooh, this could be our answer, because this is not in the general formula of an alkane. This is the general formula of an alkene. Double the carbons. Double the carbons is 6 plus 2 is 8. That's an alkane. Double the carbons is 8 plus 2 is 10. That's an alkane. This is our answer, choice 2. Which represents the product of an addition reaction between ethene and chlorine? So ethene is C2H4. How did I know that? Well, F is 2, E means double bonds. Fill in the rest. So C2H4 plus a chlorine is Cl2. Why is it Cl? What the heck? Cl2? It's a diatomic. So C2H4, Cl2. Don't you dare simplify that down to an empirical, because we have to have all of those. Looks like we're not bringing them all together into one. Looks like one of the bromines are coming in, one of the H's is coming out. It's called a substitution. That's choice 4. Okay. Come on up. Hello. Substitution. This is when you have one coming in and one coming out. So you got to have 2 products, 2 reactants. This is going to be our answer. Another way you know it's a substitution is if you have all single bonds saturated. This is all single bonds, but this is a combustion reaction. Nope. This is forming one product. This is forming one product. That means that's an addition reaction. And also I know they're addition because these are alkenes. You want an alkane. Choice 4. Thousands of identical molecules. It's called a polymer. And this is also a polymer. Those are on the other worksheet. Let me scooch down. What are we forming? This is also on the other worksheet. The formation of what? We're forming this. There she is. Old Granny Esther. How do you form Old Granny Esther? Well, Old Granny Esther lived a hard life. She drank alcohol and she did acid. So here's our acid. Here's our alcohol forming Old Granny Esther. This is also on the last one. Esters, perfumes. Products of a fermentation, we're forming alcohol and carbon dioxide. Those bubbles in beer are carbon dioxide. Fermentation means the formation of an alcohol and carbon dioxide. So who's forming the, here it is, choice 2. All right, moving down. 40. When oxygens burn and completely in an excess of oxygen. So hydrocarbons burning, this is combustion. We're burning, we're getting carbon dioxide and water. And these are just definitions, folks. Soap, figuring out what soap is, which one has the word soap in it, just kind of mixed up. There it is, codification. Now, 42 through 45 are for honors students only. If you are not in the honors class, you can turn this off right now. Thanks for watching. If you are in honors, let's continue. So if we're cracking crude oil, the whole point of cracking is to take really long hydrocarbon chains, breaking them down so we can use them for something more useful. And guys, which of these seems like the most useful? I would say not those. So down between those two, it's gasoline. We need gasoline to fuel all kinds of things. Maybe that's going to change with electric cars and whatnot in the future, but that's why we use cracking. Now, what is this? Okay, so I see that we are taking a 20 carbon chain and we're breaking it down into 2 10 carbon chains. So that's cracking. Now, if you were going to be specific as to what kind of cracking, this is called catalytic cracking. Although it does happen at a high temperature, you see the presence of a catalyst, it is catalytic cracking. Petroleum, the stuff that comes out of the ground. It's a complex mixture of hydrocarbons, and we can kind of make those different compounds from it by fractional distillation. Distillation means boiling and separating by different boiling points. Fractional means at those separate different boiling points, we can take off what we call the distillate and use it for different things. So from that, hopefully we've got our answer. Petroleum can be separated into different fractions because they have different boiling points. If they had the same boiling point, it would all boil off at the same temperature, and you can't use that. We want to use and kind of distill it down to a more useful form. Okay, hope that helps. If not, please reach out. Thanks for watching.